Okay, so the second part of our tutorial session is to show you how to actually write a program, especially a graphics program, and this will be related to your assignment. Okay, so let me just enlarge the screen. So when we want to actually write a graphics program, you will first have to think about your UI design, right? So I'll show you how the UI for this one is designed. So firstly, if you look at this particular game, right, what I'm going to show you is in terms of the screen design. So the game screen is basically occupying the entire frame in this case, right? Because you're using Java Swing, right? So I'll call this as a frame. So the entire frame consists of this size, and inside the frame, I have canvas. So the canvas part is the one that is used to draw, right? To draw, let's say, the black square, the yellow bar below, okay, status bar, blue status bar below, and the yellow dot here, or yellow square here, is used to denote the player, right? Actually, you can draw even better, right? So I'm just illustrating the concept. And on top of that, I've actually put buttons, right, on the right-hand side here for controlling the game. So by right, you could have actually used button, or if you don't want, you just monitor the keyboard input. So the keyboard input will be monitored by this particular area called canvas here. And in order to allow the keyboard events to be captured here, right, and also the UI events to be captured at the same time, you might need to actually pass the focus to the, in this case, the canvas over here. All right. So apart from that, if you have a mouse click on left button, right button, and so on, it should send relevant signal to your game so that you are able to update the screen display, right? So the update will all be done inside this canvas class, right? The canvas class. Don't forget that. So the canvas class will be doing all the updating, whereas the button here will just be triggering an event. And then inside the event, you change the variables, right? You change the variable so that your particular player here will be displayed somewhere else, right? Depending on where you go. And there's a start button that will start the illustration, because we need to have a start button. If not, then your game will be forever running, right? You don't want that to happen. If you click on start, then the gameplay will start. And in order to actually track the gameplay and updating of the screen, we will use a timer. Okay, a timer is used in this case to make sure that, okay, we count. Let's say how many seconds elapsed, then I refresh the screen. Okay, I have to redraw the screen from time to time. And that depends on your need. Like, for example, if you want to redraw the screen, you might be redrawing the screen every 50 milliseconds, for example. So if it's 50 milliseconds, that means how many times in 1 second? 20 times. Okay, 20 times. And if, let's say, the updating is not fast enough, then sometimes our eyes can see the difference, right? And then it's not smooth. So therefore, I think 20 updates a second should be good enough, right? And that's why we need to know the steps involved. So let's have a look at the code here. Okay, in order to use Swing, you will need to import the Swing library. The Swing library is very interesting because it's the only one that is actually having a Java X in front. So what's Java X? The extended Java library, javax.swing.star. So that's the only one. And as I mentioned to you, the event handlers are actually related to AWT. So therefore, it's easy for you to just use the event handlers from AWT, because those are abstract, okay, abstract classes that you can just implement, all right? So, and of course, there are interfaces that you can implement also, in this case for the event handler or key listener in this case, right? So let's have a look. First, you import the library. Next, you need to create a canvas. As I mentioned to you, the canvas will be used to display the game area, right? The game area is small in this example, only the black and also the area before the blue bar, right? So we call this as game canvas, and it needs to extend canvas so that you are able to utilize the feature of canvas to draw on screen, right? And then you need to implement listener so that it reacts to two parts. One is the so-called action, right? So the actions are all related to the UI, including your timer, all right? And secondly, it needs to react to keyboard, So there are two listeners that we need to implement. One is action listener, the other one will be key listener, right? So these are the two. And your so-called common variables are all declared in the open area here, right? So that it can be visible to all your methods, all right? So we are creating, in this case, PDX, PX, PY, PDY. What are those? PX stands for position X, right? You need to keep track of your position X and position Y of your game, right? So that's why you need to have this PX and PY as usual, right? And then how about the movement? The movement will be tracked by P delta X, P delta Y. So I'm using PDX and PDY to stand for the position delta X, position delta Y. So once you vary this position delta X and delta Y, then you will be able to show the movement, right? But of course, you need to actually implement the computation. In that case, your PX and PY will be varied by this value P delta X or P delta Y respectively, okay? So remember that. And then we have a timer that we need to actually start whenever you say start game, right? And your updating of your screen will only be valid when you start the timer, okay? If not, then your screen will be static, okay? And we are not using this Boolean, it's running yet for our version 0.1 of our game design. So this particular game, in fact, we're going to start with a very basic one, okay? Very basic. And over here, the constructor for your game canvas actually initializes a new timer, right? You know that we're going to use a new timer to basically keep track of the screen updating. If the timer doesn't expire, no updating of your screen will be done, okay? So how do we do that? Very easy. We just need to basically declare a timer and we set the timer expiry to 50 milliseconds. So the instance of timer will be 50 milliseconds and it works on the canvas only. All right. Okay. So that is applicable to your canvas class. And then we have the PX, the initial starting position of your character on position 300X. And then there should be another one for position Y, which I actually put a comment here, right? And then we add the key listener to listen to the events happening on this particular class. So that means any keyboard interaction will be monitored by this class, okay? And that is your canvas, okay? Anything on keyboard will be captured by the canvas only, all right? And take note that if you are using a so-called canvas class, the canvas class have some methods that you must implement on your own, right? What are the methods that you must implement? Firstly, you must implement paint. So the paint is used to draw and redraw the screen, okay? It's used to draw the initial screen as well as to draw the updates on your screen. So how do we actually do that? Very easy. Take note that before we draw the screen, we actually compute PX and PDX, PY and PDY anyway, right? So I leave this for you to fill in anyway. You notice that there's a blank that you need to fill in. So this will denote the traverse, or let's say the dispersion of your character from the origin, right? The origin is PX and PY. Then plus with P delta X and P delta Y, that this will be the new position, okay? Then what we are doing here is very straightforward, okay? What we do is we draw firstly, okay, the screen. Take note that we draw the screen first, okay, before we draw the yellow square. So screen, the black colored screen will be drawn for the entire 0, 0. That means you start from top left and then you draw to 600 by 600, right? So this size is 600 by 600 black. And that's precisely what you have here, the black, okay? We haven't actually drawn the yellow position yet, right? So remember that the yellow position will be drawn last. And then the next one that you draw is basically the blue bar. The blue bar starts from 0, 600. Where's 0, 600? If you keep scrolling down, then you can see that 0, 600 is actually this position, okay? And then for the drawing, in fact, you notice that the coordinate system is very straightforward. It's X, Y, width and height, right? X, Y, width and height. Width is 600 across, height is only 30. So therefore the blue bar will be a very short one of 30 size, right? 30 pixels. And next, I'm going to draw the yellow box. The yellow box is of fixed size, right? The width and height is 30, 30. All right? And the position, in this case, PX is varied, but PY is fixed. Why? And then this will be useful for games that are actually allowing the player to move only left and right, right? Like for example, have you played something like Space Invader or whatever that allows you to hit the ball back, right, to the screens, but your movement is only left and right. Okay, so that will be some of the things that you need to consider. So we are going to change the game shortly, right? But I'm just illustrating, or I'll explain all the parts and pieces here first. So the paint is basically an event handler that will be called whenever you need to refresh or redraw your screen. Okay, and the next one, action perform, is actually associated with your action listener, right? Remember that this is for action listener. So each and every one of them will be for a different purpose, right? The methods. So this one is for action listener, and take note that the action listener over here is only applicable to a timer, right? Whenever the timer expires, you will decide whether you want to draw something or not, right? So how about changing the position? The changing of position is actually done by your other methods below, right? You notice that you have methods to move left, move right, and so on. Okay, so over here, the action perform, just listen to the timer. If the timer is actually running, then from time to time, the timer will expire, right? Okay, so if the timer expires, then it will repaint the screen. Okay, for 0, 0, right, from 0, 0 up to 600, 630. Why 630? Because that includes also the blue bar, right? Okay, and then take note that you need to request focus. If not, then your listener will not be listening to the event anymore, right? So you need to request focus so that it will continue to listen and wait for the next event to happen. Okay, so the focus will be on this particular UI in this case. All right, so that is your canvas. Next, the move left and move right methods are only updating your PDX and PDY respectively. So we only have move left and move right, right? How about the move up and down? Not yet. So the up and down will be for you to implement, right? And take note that for our Java coordinate system, we will always be starting from top left, 0, 0. If you move to the right, X will increase, right? If you move to the left, X will decrease. That means you have a minus X. So if you move down, Y will increase. If you move up, Y will decrease. That means you have a negative Y. So over here, when you move left, you are decreasing X, right? So that's why you have a minus value for your PDX. All right? If you move right, you have an increase in terms of your X. So therefore, the X value is positive. All right? Same thing, if you have move up, then move up is definitely negative Y, right? And then move down is positive Y. Just for info, right? Okay, so that will be the part that you need to understand. Next will be key press. What are we monitoring here? So for key press, in fact, we are monitoring what key has been pressed on your system. And in order to actually match this, you need to use an ASCII table. In the ASCII table, you will also include those non-printable keys, right? Non-printable keys that you can actually press, like for example, up, down, left, and right. Each and every one of them will have a different key scan code. So when we say key code here, we're actually talking about the scan code of your keyboard. All right. So if you press a key event will be generated, and you can actually read the scan code in this case, or the key code, using e.getKeyCode, right? So this will be obtained from the key event. You use this method, e.getKeyCode, to get the key code. And you can compare the key code to see what key has been pressed. But we are only interested in some of the keys. Like for example, okay, take note that move left, the key code is actually 37. Okay, 37 is move left, 38 is move up. Remember that? Okay, it's not here, but it's move up, 38. Move right is 39. Move down is 40. So remember that. 37, 38, 39, 40. All right, so then you know how to implement the entire monitoring of your key press now, right? So the keyboard, left, right, up, down, will have different key code. If you want to use the AWDX, okay, the one that people normally use on the keyboard, then you need to actually look at the ASCII equivalent table, right? So then the key code is given there, right? So the AWDX will be another approach, right? Rather than using the up, down, left, right, okay? So, and take note that in order to implement the so-called the key listener interface, you will need to implement 3 different methods. One is called the key press. When you press down the key press will be generated, right? An event called key press generated. When you release, another event will be generated. Okay, so the interesting thing is that for the key listener, it actually is able to monitor key press, key release, plus the key type. Okay, so the key type consists of a combination, right? So the press and release will be one group. That's called the key type. So anyway, we are just monitoring the key press. The moment when a key is pressed, then you do something, right? So therefore, these 2, you can just leave it blank. But take note that it must be implemented. If you don't put an implementation, your compiler will complain about, okay, this particular method must be implemented because you are actually inheriting from interface called key listener, right? So therefore, you cannot run away from this. So now that I've explained the first part, let's just move this code into your program. So how to do that? Let me just start with a new project. So I'll press Ctrl+Shift+P to start a new project. And this project will be starting with the no build tools. I will start with the no build tools and I'll choose Java as the main folder. And I'll call this as a game demo. Okay. So there we go. We have a screen, new screen, game demo. And we are supposed to write the first class, which is a canvas class, right? So remember that this canvas class should be called game canvas, all right? So we are going to create a game canvas class. Unfortunately, this one is actually hiding my typing, right? Okay, so game canvas, enter. Right, so now we can just paste the code over here. And you need to actually add or remove some parts so that it is applicable, right? So now if you look at the first one, okay, this one is just nice. I've explained about the parts and pieces already. Later on, we are going to see how we can extend this further, right? First part is your game canvas. The game canvas is where all the action is, right? And you also have another one, which is your frame. Don't forget there's a frame that you must actually put into your Java Swing, because if you just have a canvas, it will not run anything, right? Because the frame is where you have your main program. Okay, so let's go down further. So therefore, this game itself, you have this game canvas.java as the first part. And the important part is your Star Wars.java, which actually covers also the main method, right, as shown below. So the main methods are all required. Okay, so let's put this code into practice now. So this is your Star Wars class. Okay, and we put in the code, and I will explain about the code bit by bit. Okay, there you go. So in your Star Wars code, as usual, since we are using Swing, you need to import javax.swing and as well as awt.event. That should be good enough. And over here, this is your front end. That means your entire screen. So therefore, you need to extend JFrame, right? So when you extend JFrame, that means you're actually implementing the entire screen. Just like in our JavaFX, you need to implement, in this case, application, right? So remember that. And then over here, because this is just a graphics front end, you notice that you just need to implement the action listener only, right? Why no key listener? Action listener is the one that you require here, because the key listener will be listening inside that box only, right? In your canvas, all right? So there you go. And this one will have a bigger size. You notice that it's 900 by 700. And you need to add all the relevant UI components like button start, button exit, button left, right, and so on, right? And at the same time, you need to instantiate an instance of game canvas, because that game canvas will need to be placed into your frame. Remember that. If you look back at your screen here, your game canvas is to be placed on your JFrame, right? So this is your entire JFrame. And you need to place the game canvas on top of it, right? Okay? So there you go. And for our constructor, you need to basically because it's a JFrame, you need to set the title, set the size, set the layout to now, because there's no manager that you want to use. And then you are going to also set the default close operation to be exit on close, right? And that's just the constructor. And by right, you need to also initialize your screen with all the components, right? So how do we actually implement the components? Very straightforward. First one, you need to basically set the boundary of all your components. Like for example, the first one will be your game canvas, right? Game canvas, you're going to set the beginning position, X, Y, and the width and height. Take note that beginning position is 25 by 25. Where is the beginning position? If you have a look at your screen here, the beginning position actually refers to this point. It's not here, right? It's here. So therefore, you need to have a slight movement down, and that's why it's 25 by 25. Okay, and then we add game C to your component display, right? Next, we add the left button. So to add the button, we need to have 4 steps. The first one is to create a new instance of that J button. Next, we will set the boundary of the button. That includes your X, Y, width and height. Okay. Next, we create the listener, right? We add a listener to this particular object. That means it's actually going to listen for any event for the action listener in Star Wars class only, right? And then next one, we need to add that particular UI element. If you don't add the UI element, it will not be displayed, okay? And all the UI elements after being added, it needs to have the action listener to set to this, all right? And don't forget the last step, set visible, okay? If you do not set visible to true, everything will not be appearing on screen. So it's just like the, okay, in JavaFX, we have this, your stage.show, right? Stage.show is a must. If you don't put that, it will not be showing anything, all right? So those are things that you must always remember. And what are the events that you are actually monitoring? Okay, so as I mentioned to you, the action performed is the only position where you are listening to action event. Action event comes from your UI. Take note that actually we will also be implementing action events on our canvas, right? The canvas has a separate action event, and whereas in our button area, right, that means your entire JFrame, we also have an action performed that's associated with action event. And what are you listening for? You're listening for the buttons only, right? The buttons will be external from your canvas, okay? So the button that you monitor will be exit. If you press exit, then the system will exit. If you press start, then it will start the timer, okay? This is the trick. Take note that your illustration or your animation will not start until you press button start, okay? Then it calls game canvas.start timer. That means your timer will start, and then it will start drawing. If you have any interaction with the UI, then the drawing will update the screen. If not, then nothing will be shown. And take note that, okay, if button left is pressed, then it's supposed to move left, right? If button right is pressed, then it's supposed to move right. But these two buttons will have no effect if start timer is not pressed, okay? So despite the fact that it's able to update your move left or move right or whatsoever, but the value will not be shown, okay? So remember that if no start timer is being pressed. And the last step, of course, this is where you contain a main, right? And this is where we need to actually instantiate an instance of your Star Wars class and call init to actually create the button and also the canvas, okay? So in essence, this is actually the main program, right? The main program. The canvas is the specific area that you need to draw, right? So the game canvas is one specific area that you need to draw. And then this init method, in fact, you can actually embed it into your constructor. If you embed it into your constructor, then you don't actually have to call it separately like this, right? If the init was called in your constructor, then there's no need to call this line, okay? So you could have actually moved it from here. We move it to our constructor, and you just call init. That's it, right? And when you run this app, okay, it shows you a screen like this. If you don't press start and you try to left, right, or you press your keyboard, nothing will happen, right? When you press start, there you go. You're able to move, right? Only left, right. And the worst thing is because there's no limit on where it can display, it can actually go beyond the screen. Okay? So this is by all means not a full program. When you press right, it goes to the right and all the way beyond your screen. Okay? And when you press left, it comes back. Right? From nothing, right? From nothing, it will still come back. Okay? Because it can go to any values that is beyond the size 600 by 600. And this can go to negative values as well. Alright? So remember that if it's negative value or if it's beyond the display area, then it will not be shown. So what should we do to actually make it in such a way that it will not allow moving beyond the screen? So all you have to do is just do this. In fact, okay, this is the area where you are updating the X and Y, right? Okay, and for the updating of X and Y, after you update, the display will be the last step, right? So before the display, what should we do? You could have actually done something like, let's say, to check for your PX and PY. If PX is less than 1, that means you are supposed to go beyond the position already, right? So then what should we do? You set PX to, okay, what's the value that you need to set? 0. Okay, less than 1, it could probably be 0 or whatever, right? Because it's minus 5, right? Remember that it's minus 5. Okay, so then you could have actually done this thing to set it to 0. And then next, if it is more than, else if it's more than, right? Take note that we cannot be monitoring on when it moves to the right hand side, right? Each of these square is 30 by 30, right? The yellow box, 30 by 30. So you shouldn't be actually monitoring up to 600 because then it won't show. 600 is already beyond, right? The square. If it's already reaching 600, that means the starting point is already on your right hand side already, right? So it should be 570. Okay, and if it's 570, then you set it to 570. Okay, right? So that will allow you to limit your X position, right? So any question? Less than equal to 1. All right, so now when you perform the action, right, we start and we move left. Will it stop or will it allow you to go? It will stop here, right? And that's why you need to know where to actually implement those functions, right? So here, what I did is basically I am forcing it to go up to, like, for example, 570, stop, right? If you allow it to go to 600, this point will go to here, and this is where you control the thing, right? Out of the screen, which is not the right way, right? Okay? So remember that. So that's why it's 570, it's not 600. You got to know the logic behind it, okay? And that's just the first part. How about the up and down button? I'll leave it for you to try out. If you are able to add the up and down button, then congratulations, right? And you can make it to move up and down. So this is the first part only. Part 1, you are learning how to actually write the basic program, right? And then part 2, of course, to improve it. So I've actually shown you how to limit the movement already. Next, let's improve it further. So the PY and PDY, they are not actually initialized, right? So you got to actually create PY. PY should start from 500. And next, right, let's go and improve on your coding here. So for PY, it needs to also update inside your paint, okay? So PY is PY plus PDY. And we need to basically monitor PDY, right? So for PDY, the same criteria will apply, right? So we will also have a monitoring for PY. If it's less than 1, then we'll set it to 0. If it's more than 570, then we set it to 570. Okay, So that will limit your position to up maximum the top of the screen, right? And after that, don't forget that over here, the fill rectangle, you have a fixed value, right? Fixed value for y. So you got to make this to py. If not, then it will just be fixed on that bar, right? You can only move left and right, okay? And because the drawing will not update up and down, you notice that, right? Unless this was varied. Okay, if you want to do a game like, let's say, your bouncing ball or whatever, Space Invader game, then that's where you need to actually set it to be fixed. But here we are making it variable. Okay, and obviously, the redrawing, everything is fine. You forgot that you need to have the up and down method, right? So let's do the up and down method. So this up and down method will be applicable for py. So therefore, we are going to vary py. If you are moving up, your py should be minus. Okay. If you are moving down, your py should be increased. Okay. So there you go. You got to actually change the pdy instead. Okay. Right. So move up pdy minus 5. Move down pdy plus 5. And obviously, you need to monitor the key press as well, right? So for key press, congratulations, right? We have already got 37, 39. How about 38 and 40? So 38 is supposed to be up, right? As I mentioned to you. 37, 38 up, 39 right, 40 down. So this will be 38. And for 38, it should be up. Right? 39 right, 40 is down. Okay? So 40 is down. Move down. Then this will allow your keyboard movement to be monitored. Take note that we only monitor keyboard event, right? So how about your button event then? So the button event is actually not in your canvas, right? So all these are the canvas operation. So therefore, you need to actually go further. Oh, I have a typo here. You have to go to your Star Wars here to implement your button up and down, right? If not, then if you run it, no button up and down will be appearing. But when you press start, your keyboard works, right? But no button yet, okay? And there you go. It stuck on top. And when you go down, it stuck below, right? And left and right will also be the same. It doesn't go beyond your space, right? So always that will be the maximum that you have defined. Okay, so that will be some of the basic criteria that you need to know. And to actually add the button, all you have to do is just come back to your left, right over here, and let's start adding the button. The 4 steps. Remember that there are four groups of things that you must do, and I'll add them in. Okay, so here we go. So next, I would need to have a button up. Okay, button up. And for the button up, of course, I need to actually put them in the right position. If they are on the wrong position, then it will not be shown correctly, right? So if you look at your left and right, the left and right is actually located in y coordinate 400. Okay, so this should be less than 400, probably 350 for up. And then it needs to be halfway between your left and right. So left to right is 650 to 750. So the middle point will be 700. Okay, so that will be for your up button. How about for your down? The down will have the same center point, which is 700. And then instead of at position Y 400, it should be about 450, right? Or if you want to make it nearer, let's put it as 425. And this will be 375. Okay, so then it will be nearer to your center. And obviously, this part is just the button, right? Don't forget that we have to have the action perform also for your button, right? So that is actually located here. And you got to actually monitor, in this case, left, right, up, and down. Okay, so for up, button up has been pressed, you call the move up from your game canvas. Okay, and as well as move down. Then you're done. Okay, every single functionality for the basic version 0.1 will be complete. So after you have done this, all your things will be ready, and you should be able to just run your app. And there you go, right? Nicely put. Position everything. When you click start, okay, and you press up, it goes up, right? When you press left, it goes left, right? The right is actually not working, right? So let's see whether I've typed anything wrong. So for the right, in fact, you notice that what's wrong with the right? Check the code. Okay. Button right, move right. Up, down is correct. Okay. And did I actually specify something wrongly for the name? Yes. What's wrong here? Down. Down becomes right. Okay. So remember that sometimes you have to be careful. Alright? So the last one is button down. If not, then it will be monitoring the wrong action. Okay, there you go. Start again. Up, fine. Left, fine. Right, fine. Down, fine. Right? So all these are done. And it will be having a limit. Okay, so this will be the limit. So if you are free, you might want to actually set pause game. Right, you only have a start button, right? The pause, reset game, right? Restart game. All those are things that you can actually add onto your screen, right? So it's very simple because you notice that the start game, if you look at it, is very straightforward. The start is just to call a start timer, right? So if it's pause, then you can actually pause the timer. And if you want to, let's say, restart, then you restart the timer. That's it. Okay? Is that okay for you? Right, so I hope you get the idea. And then you can try to actually implement those features. Right? And of course, we haven't actually used some of those things like to check whether the game is running or not. Right? So your winning condition, in fact, will be implemented in part 2. Right? The winning condition or the game over, right? So part 2 and part 3, if you have time, please go through the labs practical for. Okay, so you can go to graphics 2 and graphics 3 to get to see the more advanced topics, right? Because those are the ones that will have already got the parts and pieces implemented. If you go to version 0.2, in fact, check version 0.2, every single thing has already been implemented, right? What I've mentioned just now. So this one is a more complete view, right? 37, 38, 39, 40, all implemented. And then the actions are all implemented as well. Okay, left, right, up, down. So now you're supposed to have a starting game prompt that tells people what to do. Okay, so you need to actually add probably a pop-up screen to tell people, or maybe you just want to illustrate some text on your canvas just now, right? You just write some text on the canvas to say that, okay, to play the game, please press start. Okay, to exit, press exit. Right? And then the border collision I've actually demonstrated to you, right? So the border collision, in fact, you can actually implement it here. Okay, if you want to learn about the border collision, you can actually implement it inside your paint method, right? In your paint, these are all your border collision, right? Right, so that will limit the actions that can be done when you hit the border, right? And you can actually move all this into a method if you want, okay? So all you have to do is just move it to, like for example, it can be public. And we call this as border collision, okay? And you just need to put the code just now so that it checks for these values, because they are all private values they can actually read, okay? And then you call your border collision here, and everything's done, right? Whenever you want to change border collision, you don't have to write that long piece of code, you know where it is, right, in a method. Okay, so I hope this will give you an idea on what you need to implement. So always get to learn the best practices, okay, the good practices, and then from there you should be able to actually write a better game. Okay, and the last one, how to actually create your enemy ship that moves randomly. That's the part where I'll leave for you to actually try out. And in fact, I want to show you that you can actually apply advanced OOP concepts, right? So there could be possibly advanced OOP concepts that you can apply. And from there, you will be able to, for example, separate your sprites, in this case, into spaceship, right? So, and then the draw position and so on, it's not just going to draw for yourself, but you can actually draw it for your enemy on top. Okay, something like this. All these are common, right? The yellow box that you draw, the red box that you draw, they are common. So therefore, you could have actually moved it into a class called ship, right? So over here, I have spaceship, which is basically a common class that extends canvas. Remember that it has to extend canvas. If not, then you cannot draw, right? So one thing is it must extend canvas. And then inside it, of course, I have all the movement and so on. And that is just related to it, right? I don't need to actually monitor events because that is just for you to draw the position, right? And to update the position whenever there's a need to do so. All right? And if you look at your gameplay now, so let's go back to your game canvas. Okay, where's my game canvas? Okay, it's here. So the game canvas now is different, right? You would basically have my ship update position, my ship check limits. Check limits will be just like your border collision, right? Just now. Check the limits, whether you reach the limit or not. And in your check limits, in fact, you can even do things like, let's say, if the user hits the, let's say, the border, then it will die. For example, like for snake, right? For the snake game, if you hit the border, if you reach the limit, then you die. Something like that, right? But here, for enemy ships, remember that it also will be doing two things. One is update position, the other one is to do something on the limit. So normally for enemy will not die lah, right? It either when it reaches the end, it goes from that end coming back again, or whatever. It's up to you, right? So those are game logics that you would have to implement, right? So the gameplay, of course, you can vary all those to make it more interesting. As I mentioned to you, all those are methods that you can actually improve. And take note that I draw the position of enemy first before I draw myself. Okay, but by right, you should be drawing yourself first before you draw your enemy. Why? There's a reason for it. Think about it. Why you should draw yourself first before you draw your enemy? Because you are the first one to reach there. And if your enemy reaches there, then it will basically, okay, like for example, if you are on the same square, then your enemy will appear on top of you, then you die. Something like that, right? If let's say you are displaying your enemy first before you display yourself, if let's say you are on top of your enemy, are you dead or not? You will know, right? So therefore, those are the things that probably requires a bit of logic, right? If you don't look at it, you won't know, right? So when you look at it closely, then you can see, oh, it has to be shown that way so that it's more realistic, right? When your enemy hits you, then you die, right? It cannot be you hit your enemy and your enemy die. That doesn't work that way, right? Okay, so hopefully you get the idea of how to actually improve this game. You notice that I now can actually instantiate as many enemies as I like. In fact, I could have actually generated a random number, and here I put it in a loop to generate arbitrary number of elements of my enemy with different position, right? So this one starts from 100, 100, 210, 200, and then 300, 100. So all these are 100, 100, 200, 100, and then this will be 300, 100, right? The position. So you can actually display as many enemies as you like. That depends on how you run this. Okay, so that will be, of course, it can be variable anyway, right? In a for loop, then you start generating as many enemies with the different coordinates x, y. But always we will start from top lah, right? Because this is a top-down game, right? Shoot them up, top-down. Okay? And this is where you are initially. And with a different color, right? Your enemy will have a different color, yourself will have a different color. Therefore, your spaceship is a common class that you use to draw your enemy as well as yourself. Because all your enemy and yourself will look similar, right? If they are different, of course, you need to have different classes. But because the characteristics are the same, you could have actually implemented spaceship and then inherited by your enemy as well as by player, right? Player will inherit from spaceship, right? So your class, public class player extends, in this case, spaceship, right? Then you can actually use that. So that will be some of the good OO practices. That's why I say it's very important to actually learn OO so that you can actually shorten your game design, right? You design the common features first, and then from there, you extend the additional features for your enemy as well as for yourself. Okay? Right? Try it. So this is actually using Swing, right? Swing is probably one of the fastest to use when it comes to game drawing and so on. But of course, you can use JavaFX if you want, right? Okay, any questions? So take note of the equivalence table again, right? The one that I would like to highlight to you guys will be the equivalence table. And because those are the additional features, so if you want to use the canvas feature of your JavaFX, in fact, it can actually work the same way, right? So that's why I'm trying to highlight to you that these are the ones that are equivalent. You can actually use it, right? Learn it, and then you notice that you're able to actually use that in your JavaFX as well, right? The name will be similar. Some will be different. Like let's say image view. Of course, this will be label plus image, but you can use an image view to draw something, okay? And then these are the additional things that you can actually refer to, right? Look at it, and then you will be able to know the equivalence of Java, okay, FX and your Swing. All right. So I'll be sharing this to you. Don't worry. And once shared, then you can actually refer to those elements. Right. Let me just pause the